transition to about 15 minutes of Q&A for the first two speakers. I've seen a few questions and comments coming into the chat, so maybe we can just start off with the first one. Maybe Mike J. Cox, if you'd like to unmute, you're welcome to, and you can go ahead and ask your questions.
Excellent, there we are.
Yeah, sure. Yeah, Antonietta, I was just curious about, I think you're talking about sort of advantages of the LIM with diagnosing sources of scale and things like that. And just wanted to hear you expand on that. And as I said in the chat, I think of the climate models like you can go in and look at the heat fluxes and know what's happening and whether they're doing it right. So want to hear, you know, the LIM side of that. And you're muted.
Okay, yeah, so this is an excellent point, and I was emphasizing the advantages of using the LIM, but I didn't really meant that should be replacing the dynamical models. I think it's a complementary approach to the dynamical models. I think that what the LIM is very useful for is to really allow you to identify feedbacks about the system variables, local and also remote feedbacks. So, for example, in what I was trying to highlight today was the connection of what was going on in the Northeast Pacific with ENSO, with what was happening in the tropical Pacific. However, I agree with you that inverse model like the LIM, although encapsulate the dynamics of the system, it does so in an implicit way. So you need a dynamical model to look at the fluxes. You need a dynamical model to do heat budgets, which you would not be able to do by using the LIM. But the LIM captured the essential statistical content of the feedbacks. And I think that in that sense, that can give a very valuable complementary approach to the study of the climate phenomena in general, but marine heat waves in particular.
Thank you.
Okay, and then we saw that there was a question, maybe for Charles. Jennifer Jackson, if you wanted to unmute, you can ask your question as well.
Yeah, hi Charles, how's it going?
Again.
So yeah, just thinking about the idea of having this sort of winter mixed water from the shelf filling the deep water. I mean, that would mean that the water on the shelf is denser than the deep water in the fjords, or that the sills in the fjords is shallower than, say, 100 meters or so. So just wondering if you've thought about that at all.
No, what I did think about was, see, I managed to, we managed to actually make the water column isothermal down to some depth without really having much impact on the salinity. So then you're not actually changing the density structure very much.
Okay.
Now, when I first wrote those lines, I was thinking about this as the water that comes in as the subsurface compensation for the outflowing surface water, because we're in January here. I haven't given too much thought to what happens during deep water renewal season, because I don't know how long, as I was answering to Julie on the chat, I don't actually know how long these anomalies persist. I haven't looked at how long they persist in time, because of course, once you start upwelling season, then you kind of blow all this stuff out of the way, and I haven't actually worked out how long do you see this stuff persisting. But I think of it, we're actually turning, you know, sort of weather scale, we're actually linking here weather scale phenomenon with bottom temperatures, which gives potential for a lot of high frequency variability in bottom temperature.
Yeah, that's really interesting. Yeah. Lots to think about, that's for sure.
Yeah.
Awesome. So we had Andrew had a question as well, I think, for Antonietta.
Yeah, I see.
Yeah, hi. I was just wondering if you tried to look at some of the more recent stuff that's kind of shorter, in time, shorter scale heat waves and how it works. Because I guess I was thinking, what is the averaging period of your comparisons? So like if you had only a 1 month long heat wave, but you average over 3 months for the comparison of predicted,
right.
like
yeah.
and so
Yeah.
Yeah.
So that in fact may not work for in that case, or also, but one could also look at shorter lead times, which may, you know, I think one can still try to predict a short event 6 months or 3 months in advance, but they may be harder, I think, to predict in the LIM framework. That I think would be useful to try. For example, the most recent events.
Cool. Yeah. So I also saw that Howard might have had a question for Charles.
Yes, Charles. I was looking at those plots of temperature versus temperature. I was wondering if you're just using the standard implementation of a linear regression, which minimizes error in the ordinate, whereas you have equal error distribution in the abscissa and the ordinate. So you should be using a neutral regression.
Yes, I am using standard regression. My experiences on the East Coast, listening to people, was to stay away from neutral regression as an evil thing. But my excuse here is that I'm focused on producing proxies. I want to use one thing to predict the other, and therefore I've chosen the regression that gives me the errors related to doing the prediction thing.
I would argue you can do that equally well with a neutral regression. It's the errors are equally distributed on both axes.
Yes. No, I have been ignoring that so far, but I may have to reconsider.
I had a question for Antonietta, actually. It's
Yeah.
more broadly about limbs. Are people? I was pretty struck by the skill that the limb had at predicting. Maybe it was the limb wanted there to be El Nino in 2014, 2015. In the real world, it didn't really work out, but it recognized that there was a PMM event, North Pacific PMM event, and it created an El Nino. Are people using, so your study was mostly a hindcast study, but are people using these in forecast mode as operational tools, like as part of the plume of forecasts that we get for El Nino?
I think so. I'm not involved in this exercise, but I think some of the limb prediction are given to the, provided as, I think, like if you look at the NCEP monthly briefings, they have this outlooks for what's going on in the tropical Pacific, and they have the dynamical models and they have the statistical models. And I think the statistical model include the limb as well as like Markov models, which I think like the limb I'm using now, I've been using here, doesn't have a seasonality. So it's, but the Markov model does, and now some new advances in my group of on this methodology also include seasonality. And yeah, so it's considered in the for outlooks. Right.
Okay. Yeah, and I guess the one thing I wanted to bring up for the EPOC community at large is that very recently, within the last week, they just declared that we were in La Nina conditions, and they look to persist throughout the winter. So that's obviously going to potentially have impacts throughout the North Pacific this winter and into the spring. So I was wondering if maybe when you get back to work after this call, you could run your limb, depending on how long that takes, with today's initial conditions, basically, and see what I'm just curious what the limb would say for this La Nina event in the next 6 months. And if that might clobber some of the warming we've seen in the North Pacific. But okay. Anyway, thank you. So I see Jim Christian has a question. And Jim, I'm happy to read it for you if you're unable to or would prefer not to speak out. So Antonietta, it looks like this question might be for you. Yes. It says, I'll just read it out loud for everybody. It says the dynamics of INSO changes over time. How do we choose the time period on which to train an empirical model like a limb? Right. Well, I think in general, I would say that the longer is your time series and the more
the more reliable your operators are. I think one can actually also look at the robustness, I would say, of the operators, because the limb can be run. So it's a model at the end. So you can run it for thousands and thousands of years, and then just take chunks of the output and reconstruct your operators from those chunks. And so you can kind of have a sense of the sampling variability of the operators themselves. But I think usually I think 50 years seems to be, or 60 years seems to be like a reasonable time for training the limb. Of course, if you wanted, it's not like a tool that you can use for projections, because if the dynamics of ENSO really dramatically changes, or the mean state really change in the future, that will not be captured by something that is trained on, on historical periods. But there are also some other applications of the limb that we have used where we actually train the limb on different periods. Let's say that certain periods you have a certain ENSO characteristics, and then you have a second period with different ENSO with seemingly different ENSO characteristics. And so you can ask the question, was actually a real difference in the dynamics of the system, or is just sampling variability? So you can construct two limbs, one on period 1 and one on period 2, and see if there are statistically significant changes in some metrics, in some measure of your dynamical and stochastic operators. So I think it gives a tool for also understanding changes in that sense.
Awesome. So we have, it looks like there's just some follow-up comments from Ryan Rikashevsky in here. And then,
yes, I saw before.
I don't see a question in there, but it looks like it's good input. Any other questions or comments for Charles or Antonietta? People are still coming in, which is great. Okay. Well, if that's the case, we have a few minutes left. I don't want to cut off early if we don't have to, but we certainly could use the time later. Go ahead.
We might want to let Charles maybe vocalize the conversation he's having with Julie. I think it's pretty interesting.
Sure, definitely.
Yeah. So this is why I enjoyed last year's meeting so much. So Julie was asking me whether there was any correlation between the January bottom temperatures and the stuff later in the year. And I had sort of been working under the mental assumption that once the upwelling season kicked in, that would completely wipe out whatever temperature anomalies I was talking about. But that may not actually be true. So now I have to go look at it. Mm-hmm. And this would give a way to persist these anomalies at the bottom further into the year and actually affect biology during the spring production season anyway.
Yeah, thanks, Charles. I just thought that if there is some persistence or some sort of priming of the system that, probably does get wiped out by the upwelling pretty quickly, but even just a small persistence during that intense growing season when biology is really ramping up could be important.
Yeah, no, I mean, the thing is I should test, rather than assuming I know the answer, I should test it. I have the data. I can test this. So that's great. Thank you.
Thank you.
Melanie has a question to Mike.
I'm trying to get Mike to speak up. Maybe he had to step out for family reasons or something, but
yeah. Is Sam on? I didn't see her.
I don't know. She might be even teaching or something. Oh, good, Mike. I thought, haven't you and Sam Sadlecki and a large group of people done some work on this bottom temperature predictability issue and then using that to predict the later temperatures? I was wondering if you could talk about that.
So Sam has focused a lot more on the subsurface, predictability of subsurface conditions, and found in the Pacific Northwest, at least, that they actually get better predictability in the subsurface than they do in the surface.
Thank you. I was trying to remember the details. Right. So you looked at the predictability of the sea surface temperature, and she and Sulagna, her postdoc, I think, led some of that work on the bottom temperature. So I thought Julie might be interested in that work.
Thanks. Yes, I can talk to her about that.
Awesome. So yeah, it's 9:30. I think we've had some great discussion and questions and presentations for this early session. Awesome. I'm glad we've had so many people. We're sitting at 79 people now, -1 for Charles's second body. But to keep us going here and keep us on schedule, I'm going to pass it off to Riley to start the next session.